Hey friends, welcome to the YouTube channel all about electronics. So in this question, we have been given this D latch and these two clock signals are applied to this D latch. So here, we have been asked to find the duty cycle of the output wave. So here, this signal CLK1 is applied as the input to this D latch. And as you can see, its duty cycle is equal to 50%. Now the CLK2 is exactly similar to the CLK1. But as you can see, it is 1/5 delayed version of this CLK1. So first of all, now based on these two inputs, let us see the output waveform of this D latch. So as you know, for the gated D latch, when this enable input is 0, then irrespective of the value of the D input, the output remains in the current state. Now when this enable input is high, then the latch becomes transparent, and in the case of this D latch, the output is same as the D input. That means when the enable input is high, then whenever this D is 0, then the output is also 0, and when this D is 1, then the output is also 1. So now based on this, let us see the output waveform of the given latch. So here let's say initially the output of the latch is equal to 0. That means up to this point the output will remain 0 because up to this point this enable signal is low. Now as soon as the enable signal becomes high, then the latch will become transparent and now it will follow the input signal. So as you can see, during this time the input signal D is equal to high. That means this output will also remain high. Now at this point the output becomes low. That means up to this point this output will follow the input signal. Now after that, since the enable signal becomes low, so the latch will maintain its current state. That means up to this point, the latch will remain in the current state, and in this case, it will remain in the low state. And once again, the same signal repeats. So as you can see, the starting point of this output waveform is same as the CLK2 signal, because here we have been given that the propagation delay of the latch is equal to 0. And this is the on time of the given signal. But now if you see, then the on time of the output waveform is lesser by this time, and this time is in fact t clock divided by 5. So for the CLK2, this on time is equal to t clock divided by 2, and this time is equal to t clock divided by 5. That means this t on is equal to t clock divided by 2 minus t clock divided by 5, and that is equal to the on time of this output waveform. So we can say that this t on is equal to t clock divided by 2 minus t clock divided by 5, and that is equal to 3 times t clock divided by 10. So from this we can say that the on time of the output waveform is the 30% of the total time period. Or in other words, we can say that this duty cycle of this output waveform is equal to 30%. So from this we can say that for the given question, the answer is 30%.